I am thrilled to introduce today's speaker, Peter Sullivan. Peter is on the Solutions Architect team at Temporal. He has over 2 decades of experience in software and security, both in large enterprise organizations and startups. And he currently works with Temporal Cloud customers to help them build reliable, durable, and secure applications using the Temporal platform. Peter has a wonderful presentation prepared for you today, and I'm so excited for all of you to join the conversation. So once again, ask questions if you have them. It makes the conversation just even more fun for us. So with that, I'm going to hand it over to you, Peter.
Thank you so much, Kelly. Yes, welcome everybody. Thanks for joining today. Hopefully this will be an informative conversation and some demo around Temporal Cloud security. As Kelly mentioned, I work with our customers around their Temporal Cloud implementations and helping them obviously be efficient and productive, but also secure in those implementations. And so we'll explore the features of Temporal Cloud related to user security, application security, your data security as those features are available today in Temporal Cloud. We'll also highlight a few things that are coming on the roadmap and then leave you with some additional resources where you can explore all of these things on your own in greater depth. So first topic related to user security. As folks that are Temporal Cloud users, likely know today, there are 2 primary interfaces for a user to interact with Temporal Cloud. There's the Temporal Cloud web user interface available at cloud.temporal.io, but there's also the Temporal Cloud command line interface, TCLD or T-Cloud, we'll refer to it as times. That is the command line companion to the Temporal Cloud UI, but also allows users to execute operations against Temporal Cloud. Both of these user interfaces are subject to authentication and the authentication mechanisms that are available to you with Temporal Cloud. As highlighted on the login page on the web UI, you'll see options where you could use Google or Microsoft as default authentication providers that you can log in with. For Google, this could be your Google Workspace account. So if your organization has set up Google or Google users today, you can use that account. It could be a Gmail account that you might have, or a non-Gmail account. With the Google authentication, you're not required to have a Google email address. Our documentations will expand on this in more detail and guide you through a page where you can associate any non-Google email address to a Google account. So if your organization is not using Google, but you still want to associate your email addresses to Google accounts, you can do that and log in that way. The Microsoft authentication option is available as well. This would allow you to log in with a personal account or perhaps your organizational account. That would be something that your organizational administrator would need to allow for the use of Microsoft social logins. But that's what we support, with that option there. If neither of those are appropriate for you, you can also work with your account team at Temporal to configure any SSO provider based on SAML 2.0. This could be your Azure, private Azure AD or Okta or some other solution. This is something that has to be enabled for you within your account and does have additional cost in relation to your bill. So just chat with your account team, but certainly the solution itself supports any SAML 2.0 provider for you to log in with. Beyond authentication, there are authorization controls that are present on Temporal Cloud. And to understand those authorization controls, it's first relevant to just revisit or review the account hierarchy or I guess organizational hierarchy of the entities that you work with in Temporal Cloud. So for Temporal Cloud users, your user is associated with an account. This is a 5 or 6 character long alphanumeric identifier that is unique to you and your organization within Temporal Cloud. And there's administration options and things that can be done at the account level. Within an account, you create namespaces, right? Temporal Cloud offers namespace as a service. You don't see any of the backend infrastructure of the Temporal cluster. You just see the namespace and you're granted permissions to work within specific namespaces within Temporal Cloud. So at the top level, account level, of course, you can be a global administrator and have access to everything. You could be in a developer role, which would give you at the account level, which would give you access and the ability to create namespaces. And then, of course, administer any namespaces that you create. Or you could grant a user the ability to be read-only at the account level. For global admins, they are automatically namespace admins. So they will automatically see everything for all namespaces within the account. But for the developer or read-only roles, we can also grant namespace permissions uniquely for those users. And again, namespace admin gives all operations on the namespace, both configuration as well as interacting with workflows. There is a write-based permission on the namespace level, which gives that user the ability to operate and interact with workflows. And then there's read-only there as well. All right, next we'll talk about application security. And so, before diving into what the application clients are in the different varieties of them for Temporal, it's important to just kind of understand at a high level, the components of your Temporal implementation that are kind of owned and operated by you versus what is owned and operated by us. We operate obviously Temporal Cloud. We're providing that namespace as a service, the effective, a view into a temporal cluster, but through a namespace, and we manage all of the cluster backend and persistence and components that run there. But you still own and operate all of your worker applications, all of your temporal applications, the things that are actually running workflows and running activity tasks. All remain within your control and under your governance and your runtime environment. So you have the full availability to secure these aligned with all of your industry or organizational best practices. Whatever you're applying to your application security processes and deployments today, you can continue to do that with the applications that you deploy that integrate with Temporal Cloud. How those components integrate with Temporal Cloud as well, they connect to Temporal Cloud over a gRPC connection. All the traffic is egress traffic. You don't need to expose any ingress ports or ingress activity from a network perspective to allow Temporal to talk into your environment. It's your environment that is communicating out over that long polling gRPC connection. And that is secured by MTLS, and we'll talk about that in a little bit more depth in just a moment. Temporal Cloud is a SOC 2 Type 2 compliant solution. So we've achieved that compliance and are obviously adhere to the standards within that. And then finally, while the default connection that Temporal Cloud exposes is over kind of the internet and that egress traffic flows out over the internet. If you are in an Amazon environment, we can set up Amazon Private Link for you. So just know that that's another option in order to, from a network connectivity perspective, to allow your workflow workers, activity workers, your Temporal clients to connect to Temporal Cloud without routing that traffic over the internet and utilizing the Amazon backbone for that. Okay, so similar to the user discussion, what are the key application or client interfaces when we talk about application security with Temporal? So first and foremost is the Temporal SDKs. It's the applications that you write using Temporal's language-based SDKs, whether it's in Go or Java, TypeScript, .NET, Python, PHP, any of the languages, of course, that are supported by Temporal. You write and run those applications using the Temporal SDK. The SDK has a client which connects to the Temporal server. And then there's also the Temporal command line interface. So this is different than T-Cloud. So T-Cloud is, again, specific for the cloud kind of operations and administration and user operations that would be present on the web UI exposed in a command line. This is for now interacting with, workflows. This is useful for both open source and Temporal Cloud, but relevant to Temporal Cloud as well as another application client that is going to communicate, with that over that gRPC connection to a namespace. All right, the security between your application clients and Temporal Cloud is secured with MTLS. So that is mutual TLS, and so that requires certificates. And so the first thing that y'all need to create for your organization or leverage is a certificate authority. You may have a standard CA in place. You may have a self-signed or open source solution that you use to generate certificates, or you could use a vendor solution, from the likes of folks like Amazon and Amazon's private CA. Temporal Cloud supports, and works with any of those solutions that you may use to generate your certificates. But your first step is to generate that certificate authority. And that could be not only just the root certificate, it could also be a chain if you're using intermediate certificates. That is effectively up to you in terms of how you want to design that, but your account team and solution architects are here to help and chat through those questions as well. With that certificate authority, you are going to generate and sign an end entity certificate. So this is the client certificate that will be used. The client will present the certificate in order for validation against the CA certificates which are going to be configured for a namespace. So when you have your certificates generated, you are going to upload the CA certificate into Temporal Cloud per namespace. And we'll do this in the demo in just a moment, so we'll see this in action. And then you're going to utilize those client certificates in your Temporal client or your SDK. And that is going to allow for that successful connection to occur. So again, the client certificate signed by that root CA or intermediate CA as part of that chain is going to be used to validate that end entity certificate, and that client program also is going to utilize that client key or that private key as part of that MTLS authentication and SSL negotiation. Bear in mind, there is a maximum of 16 CA certificates that you can upload in a specific namespace. The certificate requirements are fairly straightforward and requirements of just common generated certificate formats and types. X509 v3 can use either the RSA or ECDSA algorithms. Your certificates should be a private or internal CA. So this certificate you don't want to use, although it is technically possible, you don't want to use a public or well-known CA like something from Let's Encrypt or another CA provider, because that would potentially expose that route to be able to use to generate other certificates that could potentially have access to your namespace. We'll talk about how to kind of lock down that certificate access in just a moment as well. But avoid using public or well-known CAs and rather generate or leverage your own private or internal CA. And then the identity certificates must have just a usage component or attribute of that certificate that includes digital signature. That's just part of the specification of certificate generation. Important to note that private keys always remain in your control, right? You don't need to upload the private keys to Temporal Cloud in any way. Keep your CA private key certainly locked down. And then on the client side, you'll have to provide the private key to the client, but that never traverses the wire. Temporal Cloud never sees anything related to the private key, no key material there. When we generate certificates for a client to use, we want to limit the scope that certificate can be used for to a single namespace. Ideally, again, this is not required. Temporal isn't going to prevent you from using the same certificate to talk to multiple namespaces, but just not a great idea, from a separation of concerns and security perspective, right? We don't want the dev certificate to accidentally be able to connect to the production namespace or vice versa. So when you are scoping your end entity certificates to a namespace, there are two primary options that you can consider. One is issuing separate root CAs for each namespace. Every namespace would get its own root. Those roots or intermediaries would generate unique certificates. And by default in that chain of trust, those certificates would only be able to use to connect to that namespace. If you have lots of namespaces, or potentially if you just want to minimize the administration of root CAs, you can use the same root CA across multiple namespaces. And then you can configure an additional level of validation called certificate filters to authorize access or client connectivity to that namespace. So certificate filters are a way for us to check certain fields that are present in specific certificates to make sure that those certificates can uniquely connect to that namespace based on that filter. So we can apply filters, to validate the common name or organization, organizational unit, or SAN fields that are present in those certificates. So as you generate certificates with unique values, you match them up with the filter in order to validate those values are present in the certificate. Each of these fields is effectively optional. Every one that you fill out must be matched. So if you add more than 2 fields in your certificate filters, then it's effectively an and operation, right? They would have to match both the common name and the organization. Wildcards are allowed for field values, either at the beginning or the end. And Temporal Cloud does do some validation that if you are using a well-known CA, I know on the previous slide we recommended not doing it, but if you are doing it, then you have to create a certificate filter in order to create your namespace. This is all part of your namespace creation. And you'll be prevented from creating a namespace if using a well-known CA without a filter. And there is a limit of 25 filters max in a namespace currently. All right, with that in place, let's jump in and get hands-on with this. So what we're going to be exploring is obviously some of the topics we've covered today so far, as well as the example applications for establishing through a temporal client SDK a mutual TLS connection. This is a Hello World style application. This application that we'll use specifically is from TypeScript, but these sample applications are present in every temporal samples repository. So whether you're using Go, Java, TypeScript, Python, PHP, or .NET, you will find a Hello World MTLS example that will help guide you through the client side, the configuration of the use of certificates to connect to Temporal Cloud. One note is just Java is slightly unique in the certificate formats that the Java SDK leverages. So generally kind of certificates, your common certificate generation will emit a certificate in a PKCS1 format. We're not going to go into the differences of the format, but that would be what the default kind of cert might be. But Java and the Java sample specifically requires the PKCS8 format, but the Java SDK also supports PKCS12. There's documentation around this as well. So if you have certs in PKCS1 and you just need to convert it to PKCS8 for Java, it's a one-liner command using OpenSSL tooling to do so, and fairly straightforward. All right, but let's jump into the demo. So here I am, at cloud.temporal.io. They've redirected me to the login page, and as we talked about, I have the standard options to log in, whether it's Google, Microsoft, or my enterprise SSL for SAML. I'm going to leverage the Google authentication and log in with a Gmail account that I have that has access to this namespace, or this account, I should say. Within this account, we have a number of existing namespaces we'll explore. But on back to the kind of the user security options, we can create and invite users to our account. If I wanted to invite a new user to this account, I could do so for Alice at example.com. I can choose her account level role, whether that's global admin or others. As mentioned before, if it is global admin, that user will automatically get access to all namespaces at the namespace admin level. If it's a level other than global admin, now you can pick and choose what you want that user to have access to for individual namespaces. So we could grant namespace admin or write or read only as described. But I've already set up users for my namespace, so we're not going to do that again at this point in time. We're going to jump into the namespace and now look at some of those namespace configuration options from a security perspective. I can see here, I've just put in a placeholder certificate because a certificate is required when you create a namespace, but I want to walk you through a certificate generation process and establishing a new CA as well as entity certificates that you would use for your environment. So we're going to go ahead and edit our namespace. We'll temporarily just clear out the certificate, and now we'll need to generate a new certificate, a new CA, and obviously there's documentation that we link to about how to do that. But I'll again provide that in demo here. So I'm going to go into my Hello World MTLS directory, and I'm going to create a certificate. I'm going to use a tool called CertStrap. It's just an open source tool. Again, many tools can be used to generate and bootstrap internal certificate authorities and certificate management. It's just one that I find easy to use here. So I'm going to create a new cert. I'm going to give that cert a name that is just associated with my account, just from a naming convention, so I know that I'm using this cert in my SDV DW account. I do have access to other accounts within Temporal. This is going to generate that certificate file, this output file here, sdvdwca.cert. I'm going to go ahead and copy that file into my pasteboard, and I'm going to paste that into the CA certificates field here, and we'll go ahead and we'll save our configuration. Temporal, the Cloud UI will now parse and validate that certificate, and so we can see this is the new certificate SDVDWCA. It has been successfully accepted by Temporal Cloud based upon the way that it's generated within CertStrap. All right, the next thing we're going to do is we're going to generate our end entity certificates. I guess I will say one other additional validation that you could do on your certificates is you look at OpenSSL. If you were experiencing errors with in any of the certificate generation, we can use OpenSSL to to show us the information within a certificate. And I'll do that just quickly for the CA certificate as well that we generate here. And that will give us back, a lot of information, a bit verbose, but it will show us things like we've created an X509 certificate. It is a CA certificate. It has that CA equals true attribute associated with it. It was a self-signed issuer, but it has that subject common name of SDVDW. So OpenSSL tooling is also convenient to validate our certificates as we go. All right, the next thing I'll do is I'm going to generate an end entity certificate that will be used by our clients, either the CLI or the application, to be able to connect to Temporal Cloud. Again, I'll use CertStrap. I'm going to generate a certificate request. I'm going to give that certificate a common name of webinar.sdvdw. Just a convention that I like to use, again, scope those certificates to a namespace. So in this case, I'm just giving this certificate the namespace name. So I know by naming convention, this is the cert I should use for this namespace. And then I'm also going to sign that certificate with that certificate authority. So that new cert CA I created, SDVDW, is now going to be used to sign the certificate. So now I've obviously created that trust relationship between these two, and this certificate will be able to be used by my clients. So this process has generated a couple files for me, that key file, that private key, as well as the certificate file that we saw visualized on those slides earlier. So we have those two key pieces of information, the certificate and the key. Again, I can also use OpenSSL to take a look at that certificate in its gory details. We can see we've satisfied X509, the key usage of digital signatures present in that cert, signed by our issuer CA, and now this has a subject CN of webinar.svdw. So with this information, I can now apply a certificate filter to now, again, ensure that this certificate and only this certificate can connect to my namespace. If I didn't put the filter in at this point in time, any certificate signed by the CA could, but I want to make sure that only the certificate that is for webinar SDVDW is going to be allowed to connect to this namespace. If I generated my certs with other metadata information like organizational unit, I could put those in as well. But at this point, the only information in that cert that I'm going to use to validate in the filter is the name or the common name there. And so we'll save that as well. All right. At this point in time, after I've created an initial certificate in my namespace, I like to use the Temporal CLI to validate that I've set this up correctly. So the Temporal CLI has obviously a bevy of commands that are available to you, to operate and work with your namespaces. One command just to check, kind of connectivity and that the namespace is present is the namespace describe command. I'll throw up the help option. We'll make this a bit bigger. And just to highlight that when we run this command, we can pass in command line parameters like the address and the TLS certificates and keys that are used for a client to connect, or we can set those things in environment variables like the $ temporal address and TLS cert and TLS key here. So for me, that is what I'm going to do just to minimize typing here. I have a pre-created environment variable file that I'm just going to source into my terminal here that is going to set those environment variables for me to use. And so now we can go back to that describe command. One thing I'll try to do just to highlight, where things might go wrong or in error scenarios, if I try to use this certificate to connect to another namespace in my Temporal Cloud environment, of course, of which the certificate CA and the filters would not allow the certificate, you're going to see an error come back from the namespace describe command. And in this case, it's very clear request is unauthorized, right? I'm using the wrong certificate in the wrong namespace. I haven't configured that correctly. But let's try that again. Of course, we know the right namespace where we have set this up for is that webinar namespace, and now we're successfully connected to Temporal Cloud. So we've generated the certificates for our namespace correctly. We're able to use the environment variables to set that information for our CLI to allow the CLI command now to appropriately authenticate itself to Temporal Cloud for that. One final command is if this was failing as well, and we wanted to drop down to OpenSSL commands, we could do that too. There is information in the forums and the docs around this as well, but you can use the OpenSSL client command now to validate your setup, right? This, again, I'm just going to leverage the environment variable as I set up, connecting to a temporal address with the right certs and keys. And this will give us, again, a lot of information back. There are some key parts of this information that show that we are successfully connected, such as the connected return value, understanding what acceptable client certificates are, like the server has reported to us that which client certificates we used, and that the SSL handshake has been successful in using those certs. All right. But of course, you want to get your actual applications, your temporal, workers and activity workers and workload workers and temporal clients connected to Temporal Cloud. So after this initial validation with the CLI, let's go make that happen as well. So I am going to use one of those Hello World samples. I'm going to use the TypeScript sample. We'll bring this up in Visual Studio Code. We'll just take a quick look at it. We're not going to go through the code in all of its detail. But we can see, within the client configuration settings, when we're creating the connection object now, what we need to do when connecting to Temporal Cloud is complete the TLS section here and specify the client certificate pair, that certificate file, CRT, and the key file. If this was an application that we were running outside of Temporal Cloud before moving onto Temporal Cloud, we might not have had this section present in our file, right? Our connection object might have just included the address, but not the actual certificates. This sample is also set up to gather that certificate information from environment variables. So I've just made sure that those environment variables match up with what I already have set in place here. And of course, the same configuration is done in our workers. So the workers are also going to utilize the TLS connection as part of, or TLS configuration as part of the connection object to set that up. So let's just go and make sure that that is kind of working with those environment variables we have in place. We'll just go ahead and run this sample. I'll start the worker here, and then I will also run the workflow itself. From a client perspective, we see that what appears, of course, to be a successful execution of the workflow, going back and just checking within our webinar workspace. So we can see just at a moment ago, we'll make this a bit bigger, but in my local time here, at 11:30, we had that successful run of that workflow. So that's, the second test I like to do after I set up a namespace and get my certificates correct here. Now I've confirmed that the CLI can connect successfully with the certs. I've confirmed that I can successfully run a workflow with Temporal Cloud with the proper security implementation in place. All right, so we'll shut down that worker. We'll come back here in a moment. But let's jump back into slides for the data security section of Temporal Cloud Security. So Temporal Cloud and really Temporal OSS as well can provide end-to-end encryption for any data that is is being used by any component in the system. Data in transit, again, is secured over or encrypted over TLS. That is for Temporal Cloud, it is TLS version 1.2 or greater. So you do need to be at least, the clients do need to be compatible for TLS 1.2. And then Temporal Cloud does store data in its persistent store, and all of the data that Temporal Cloud stores is encrypted at rest as well, using AES 256 GCM. What's important for you to know is Temporal Cloud doesn't process your data. We don't need to decrypt data or actually understand anything about the data in order to orchestrate your workflows. And so while we encrypt the data at rest, you also may want to encrypt the data with your own keys, or perhaps just ensure that your data as part of the Temporal solution, is not visible to Temporal in any way. So protect your data. You have two primary options. One is just don't send it, right? Your Temporal Cloud or client, I should say, SDK program, can choose not to send data payloads to Temporal Cloud. You could only send references to data. You could store data in your local persistent stores within your environment that you have full control over, and just never pass data through to Temporal Cloud as part of workflow inputs or activity inputs or whatnot. Of course, you pass references in so that when the workflow executes, it can dereference the data and then use that as part of it. But that is your primary option if you're worried about sensitive data within your temporal implementation. But the second thing you could do, in many cases, it does make sense to pass payloads in rather than references, is to encrypt that data with your own keys. And this is enabled by a facility of the SDK called the data converter. And so the data converter is, a component of the Temporal SDK. It allows you to serialize and encode data that is entering or exiting a temporal cluster, and conversely deserialize or decode that data. So when we enable the data converter as part of the SDK is working on decoded data. But any operation, where that data is sent through a part of the event history or, payloads that are recorded in Temporal Cloud, that data will automatically be encoded by the data converter component within the SDK. And so that remains all within your environment. What is on the wire and what is seen by Temporal Cloud is only encrypted or encoded data. And then when the temporal client retrieves data from Temporal Cloud, that's run through the data converter with the reverse operation. And of course, the decoded data is now present in that. We'll continue to explore data converter in an upcoming slide and demo, but just be aware that the data that is run through the data converter are, the arguments to workflows, signals, queries, the return values for those, as well as activities. Arguments and return values. There are data components that are not run through the data converter. Those would be kind of the identifiers or types or names of tasks and task queues. Search attributes is a key one there. If you are worried about sensitive data, perhaps PII data that could be present, through the interfaces to Temporal Cloud or just within Temporal Cloud itself and not encrypted by your own keys, you would not want search attributes to contain any values of personally identifiable information. And then failure messages as well, although there is a separate failure converter that you could use to convert failure messages, but just by default, they don't go through the data converter. All right, there is a default data converter in place for every SDK, which automatically kind of serializes those data elements to payloads that are stored by Temporal Cloud. And so that default serialization, applies to the common serializable types that are present in that data or in the SDK, and converts that binary data and attaches some metadata to that binary data as it stores it in Temporal Cloud. But we can add custom payload, and the way it does that is through a payload codec. And we can implement custom payload codecs for any other operations that we want to perform on that data before it's sent to Temporal Cloud. And so that's a common use for the payload codec is for encryption. You could use the payload codec for compression or other needs as well, but certainly encryption is a very commonly used one for that payload codec. Payload codec is just kind of an interface that has two functions that you need to implement: encode and decode. Again, you can choose to do this however you want. You can use any encryption algorithm you want. You can use any keys and key sizes you want. You keep all of that on yours. Again, on your side. Temporal Cloud has no need to understand how that's encrypted or the keys to encrypt it, right? So you can guarantee that that is unviewable, unseeable, unknowable by anybody on the temporal side. And then once we've implemented a payload codec, we can add that to the data converter, and then it's simple as adding a configuration element to our client connection for that data converter. Once we've put that converter in place, now when we look at information through the interfaces for Temporal, whether it's the UI or the CLI, what your end users now, your operators, your workflow developers are going to see is encoded data. By default, right? Because everything that Temporal Cloud has is just encoded or encrypted. But we can allow those users to see unencrypted or unencoded data or decoded data by configuring the UI or the CLI to leverage a codec server to perform the decoding and decryption. So we would set up kind of the same, encryption algorithm or configuration in our codec server as we set up in our data converter and payload codec, so that they are compatible to do, the encoding and decoding operations successfully. The codec server is an HTTP or HTTPS server. It exposes REST APIs. You would implement, like you did in the payload codec, the decode and the encode endpoints for that server. The server, again, now receives those payloads as JSON directly from the UI or directly from the CLI. None of that information goes back through Temporal Cloud. For the UI to be able to connect to the codec server and pass information back and forth, because this is all client side, we're in the browser sandbox, we do have to configure cross-origin resource sharing in our codec server, or CORS. Don't worry about that. I mean, all of our examples contain that configuration and what's required to enable CORS namespaces. But of course, you can read more up on CORS and why that's a requirement for the UI to be able to communicate with an external domain or HTTP server there. And then the codec server can process information, or your implementation can process information per namespace through the namespace header. And you can also require authentication to your codec server by passing in an authorization header that, again, that your codec server implementation would then validate. Within Temporal, the codec server can be deployed either locally or centrally, or really, I should say, within your environment. You could deploy the codec server locally or centrally. So as a developer, I could run a codec server on my local host environment, or I could set one up for my team at a shared domain and shared URL. But within Temporal Cloud, you now can configure the use of that codec server for kind of your team at a namespace level, or individual users can override that option. We'll check out both of those in the demo, but you can set up defaults for everybody to use the same codec server, or you can have individuals use unique ones. If you are using authentication through the authentication options with the codec server, then your codec server must be HTTPS. We're not going to pass an authentication token over a non-secure connection. And that authentication token can come from two places, or one of two places. It could be the Temporal Cloud JSON Web Token itself. So we can pass the end user token that exists for Temporal Cloud in through to your codec server, and you can validate that token using Temporal Cloud's JSON Web Key Set, or JOCS. And so that information or the location of the JSON Web Key Set is here. And so you can download that key set or leverage that key set to do, again, the signature validation of the JOT token from Temporal Cloud. Or conversely, you could just implement your own credential mechanism. And then you could include that credential after the user has logged in your own way to the request for the codec server. And that's what the second option here is, to include cross-origin credentials. This will include in the request the credentials from the origin, right, from your codec server, which is the cross-origin in this case. All right, well, let's check out data converter and codec server in action through demo as well. So I'm going to come back to my terminal. We'll navigate out of the MTLS demo and into the data converter here. And again, I'm using another one of the samples. And in this case, also TypeScript that are present in the samples repositories. But I've made a slight modification, and we'll just check this out first. So I'll go ahead and I'll start that application worker, and then I will start a workflow as well. And we can see, within the local output of the workflow, Alice and Bob are exchanging private messages, which ultimately we will want to encode and encrypt in Temporal, so that you have full confidence that your data is protected on the Temporal side. But looking at this within our workflow run execution, we can see my new data converter workflow just ran. We'll open this up and take a quick look at the inputs and the outputs. And at this moment, the inputs and the outputs are not being encrypted or encoded. They're just coming in clear text, the same way they did for the previous Hello World issue. And so let's take a quick look at the code and to see kind of why that is, or why that might be. And so here, what I did just kind of temporarily comment out, just for the purpose of example, is the new parameter that we need to add to those client connections. So again, configuring that data converter, once you've implemented a data converter, is as simple as adding it on to the client connection parameters. So I wasn't running this client or this workflow with the data converter in place. We'll comment that out to get that going. We'll also take a quick peek at what that data converter is. Again, it is, obviously the data converter is using the default data converter within Temporal, But now, as part of that list of payload codecs that we have implemented here, we're implementing our own custom encryption codec that is now going to participate in that chain of coding and decoding that happens when a payload converter is run. And that encryption codec, as we briefly talked about, just implements the encode and the decode functions. Again, all the sample code is available in the samples repositories for all of the SDKs. You can change it. Obviously, not advisable to use in production the sample as is. You want to choose your own encryption algorithms and encryption keys, but this has everything you need to get started to do that. All right, so we'll get the data converter in place for both the client and in also the connection options for the worker. And we'll go ahead and we'll run this this worker and this workflow one more time to show that we now have encryption in place. And so we're getting a bit more output just from the workflow itself. This is just the way this workflow is written to identify that it has going through decrypting payload. And of course, the workflow output on the command line is clear text, but in this case, Temporal Cloud should not have any knowledge of that clear text at all. So we'll go back into the next workflow run, and we can see that the workflow inputs and results are now being successfully encoded. So this is great. We've achieved on the client SDK side the ability to encrypt our payloads automatically that are sent up to Temporal Cloud and ensure that it's done with our own private encryption keys, and neither Temporal Cloud nor anybody at Temporal, would ever be able to view any of this data. But as we talked about before, now that this data is encoded within the Temporal Cloud server, encrypted within the server, by default, we can't see it ourselves. Within the UI, and the way we enable ourselves to see it in the UI is by implementing a codec server. So I just had a previous value in the codec server here, but I'm gonna within the codec server, again, we have those options to use namespace level settings if they've been set for us by an administrator, or our browser settings. And local settings. Right now, I'm going to use my local settings, but I need to get a codec server up and running. We certainly have examples for all of those as well. So I'm going to go back into the codec server. In this case, this is an example from the Go samples repository, and we're going to go ahead and we're going to run that codec server in that environment. Whoops, I wanted to just put that into the background for a second. All right. If you're now, we'll return to the UI in a second, but for this specific workflow I run, I'm going to grab this workflow ID, and I want to show how we can use both the codec server on the CLI as well as on the UI. So from the CLI, we can run, the temporal workflow show commands and to view a workflow. And in this case, I'm just going to pass in that workflow ID. And we see that even from the command line, we're getting the same view of the data is encrypted and we can't see it. But if I want to automatically decrypt that data, now I can pass in the codec endpoint. And I'm running my codec server on just localhost port 8082 here. And so with that codec endpoint now passed along to the command, we are getting automatic decryption of that, and I can see that within the command line. So similarly, we can add this to our UI configuration. And so I'll just go back and set this. Oops, and we'll dump. We'll put the URL for localhost into our UI, and we'll apply this to our environment. And now, hopefully, we would have started to see decoded data, but we're still not seeing it yet. And we can see the eyeglasses icon within Temporal is indicating that there's some sort of error at play here. And I want to bring you through just a quick debugging of this error. Since this is all browser communication from the code, the JavaScript that exists in the browser to the codec server, there are no server-side logs for us to view. So we're looking into the browser-side debugging, and I'm going to bring up the developer tools and console for the browser here. And what we can see in the console of our browser is we're clearly running into issues with cross-origin resource sharing, right? We have the server has not satisfied, our codex server has not satisfied the course policy. There's specific headers you need to set within that server, again, covered within our documentation, but we know clearly now that this is a CORS issue that we need to resolve. I do have a second endpoint on my codex server that specifically solves the CORS issue. So we'll change that to localhost 8082/CORS. We'll go ahead and apply that, and boom, right now we're getting our eyeglasses look good, no more red there, and we're getting automatic decryption of messages there. All right, the final part I just want to show is in a different namespace that my teammates have set up, Steve and Keith and others from the solution architecture team here, where they have gone ahead and configured the codex server as a namespace configuration element. So again, what's convenient is you can configure codex server locally, or you can configure it for everybody in your namespace. They've gone ahead and they've provided this for everybody on the team here. This namespace is supporting the orchestration of workflows for a flight booking app, again, that Keith has written, and I'm just going to walk through this. It's a bit more robust in terms of a real world application utilizing Temporal for durability of execution. But we're going to go through, find a flight to book, select that flight, and choose our seat, as well as enter in our payment through a credit card number here, and confirm that payment within the application. Back on the Temporal side, we can see that a new workflow execution has run this payment workflow just a moment ago. And we'll take a look at that in a second. But I want to, intentionally, somewhat break something here. I want to utilize the codex server that the team has set up, now more of that central codex server versus a local one, and apply that to this namespace, and then go take a look at this workflow. And within this workflow, I'm still seeing encrypted or encoded results, and my eyeglasses are red again. So back to our troubleshooting approach, let's go look at the browser console. Sorry, just the zoom controls there. And we can see that we're getting in the browser a number of 401 errors, right? That's the HTTP code for unauthorized. So there's authorization that's required here that is not being passed through, and we're getting blocked with that. Of course, I know from chatting with Steve and Keith that they have set up authorization on this codex server, and that needs to be configured. And specifically, they're using the access token from Temporal Cloud. So they're using the JSON web key set to validate this access token within their codex server implementation. So we'll pass that access token through, reapply our settings. Our codex server is now happy and no longer red, and we can see inputs and results. But the final, more interesting thing here that I want to highlight is that in this case, Keith and Steve have taken the codex server implementation a bit further than just encoding or encrypting the entire payload. But this token is related to the credit card number that I passed into this payload, and they're actively redacting just this individual field, just this individual element in their codex server in the UI here. So even though they want workflow developers or operations folks to be able to see decrypted payloads, they're leveraging that payload codec to redact individual fields. So you get great flexibility in terms of anything that you might want to, however you might want to process payloads in those codecs. Cool. That completes the demo part. So let's kind of just jump back to slides, and we'll wrap up. As I mentioned, we'll highlight a few things coming on the roadmap. One is improvements around our MTLS implementation. We will, again, there's a variety of tools you can use to generate your certificates. We're going to build in some certificate generation capabilities directly into T-Cloud. So you won't have to leverage an external tool if you don't want to, but you certainly still can. We're not going to prevent that in any way. It will all work as it is today. And more proactive notifications for certificate expiration so that nobody gets caught by cert expiry. As an alternative to MTLS, not a replacement, but a new alternative, we're introducing API keys. So this will now be an authentication alternative rather than all the certificate work that we did to set this up, where we can use API keys within our workers, within our command line applications or command line tools and API applications as well. API keys will also be tied into the RBAC model. So those things that we talked about, the account level roles and the namespace level permissions, will be available to be bound to API keys there. And then finally, your identity provider or SSO repository sync. So we're calling it IDP sync. So today, your identity provider and SSO, if you're using SAML, is only used for authentication, and there's no automatic synchronization of those users into Temporal, but we will be syncing those in to understand, the onboarding, offboarding process or joiner levers for those, as well as tie groups in your authentication or IDP model directly to RBAC permissions. So you wouldn't have to explicitly set up RBAC permissions for users within groups within your IDP. And then finally, here are the key resources that kind of I chatted about or mentioned or used in the demo. Again, my colleague Keith, the Temporal Flight Booking application is available on GitHub, as well as Steve's Temporal Codec server. Again, that takes the sample. There are sample codec servers, of course, but that takes it a bit further, and that it adds that JSON Web Token authentication. So if you're looking for an example of how to add that JWT authentication to codec, that's a great example to follow. Of course, the samples repository is mentioned a bunch of times: samples in Go, Java, TypeScript, Python, PHP, .NET. They're very, very comprehensive. I use them myself almost every day. So whenever you're looking to do anything in Temporal, but certainly around the topics we've talked about here, MTLS, codecs, data converters, encryption, there's great samples to reference from. And then finally, the resources in the Temporal documentation. So under the cloud section, getting started, we'll walk you through the MTLS configuration. Under the concept section, data conversion, we'll walk you through data converters and codec and code samples there. And then there's just the entire security section as well, which is worth a read. With that, this part of the webinar is complete. So thank you all so much for joining and hanging in there with us for close to an hour here, and happy to turn it back over to Kelly for any final questions or wrap up.
Thank you so much for everyone for joining us. And Peter, thank you so much for your time too. Really, really enjoyed your presentation today. And yeah, any last words from you, Peter?
No, yeah, thank you all. Thank you so much, Kelly, Keith, and Steve as well for handling the questions, as well as the other contributions to the content and the demos here today. So happy to have brought this to you, and hope you all found it informative. And again, if you have any questions, feel free to reach out to your account teams. All of us as solution architects and dev success are here to help with any of these topics as well. So.